In the last video, we were discussing the leading coefficients of polynomials. Now let's discuss the degree of polynomials. And it's going to be different based on which format they're in, just like the leading coefficient was different based on the format they were in. So let's start with standard format. When we're discussing the degree in standard format, it is strictly the largest exponent. Think about it. These polynomials right here, these four that we're looking at, are already multiplied out. So we already know the largest number of x's that have been multiplied out. So like in this f of x, my degree is going to be a 2, because that's how many x's, when I've multiplied out, factored out, anything like that, that I'm going to have. So g of x, the degree, and it's a little bit hard to tell here because I have that circle around it, there we go, is going to be a 3. Here, that degree will be a 3. And here, the degree is a 3. Now, it's important to know what the leading coefficient sign is. Not necessarily the number, but at least the sign. And the degree of the polynomial. And we'll explain in the next video why. But let's look at what happens in factored format for the degree. So when you're looking at the degree, wherever it's in factored format, think about the fact that we've got to multiply all of these things together to get it into that standard format we were discussing in the previous page. So if I were to multiply all of these factors together, what would my largest exponent for x end up being? Well, what it is I'm going to add the exponents for all factors with a variable. So I'm going to go through there and look at the factors that have a variable. So this factor has a variable. It doesn't have an exponent, but what is the understood exponent of anything that doesn't have an exponent? Well, the understood variable, the understood exponent, think about what the exponent of this x is. It's a 1. So this factor has a variable. Its exponent is a 1. This factor has a variable. Its exponent is a 1. This factor has a variable. It already has an exponent. So I'm going to take and look at the exponents, and I'm going to add those up. So I have 2, 3, 4, and 5. So the degree of p of x is going to be 5. Because if I were to multiply all of these things out, I would end up with an x to the 5th. And actually, in this case, I would end up with a 20 x to the 5th as my leading term. Now, whenever I multiply these out, does this factor have an x or a variable? No, it's just got a number. So I don't need to add the exponent for this one. Does this factor have a variable? Yes. So I need to take that exponent. Does this factor have a variable? Yes. So I need to take its exponent of 1. This factor has a variable. So I need to take its exponent of 2. This factor has has a variable. So I'm going to take its exponent of 1. This factor has a variable. So I'm going to take its exponent of a 1 as well. 4, 5, 6, 7, 8, and 9. So this would have a degree of 9. So my leading term for c of x would actually be a negative 18. X to the 9th power would be my leading term in this case. Now again, it's important to know what the degree and the leading coefficient are for these polynomials, because those are going to help us graph them, which we will discuss in later videos.